So we're going to have a fun series of data visualization techniques that we're going to look at today. We're going to start with looking into some more of the data-defined overrides that I tried to show you last week using that darker function. I have some more thoughts on that, which I'll share with everyone at the beginning. And then we're going to look at a little more in that direction with the geometry generator renderer. And then we're going to move into working with the 3D viewer in QGIS, so you can see how to work with that. And then work with the temporal controller, which allows you to work with time in QGIS. So it's kind of interesting because, you know, most of our normal data have X and Y coordinates. And then in the 3D environment, we introduce Z values, the third dimension, and we can almost think of time as the fourth dimension in a way. And so a lot of geospatial data have a time component as well. And so I think this temporal controller that QGIS has introduced in recent years is a really powerful tool. So we'll get to see a couple applications in which you can work with that, the last of which will be weather-related mesh data. So if you haven't worked with mesh data at all, you'll get to experience that as well. So first off, let me bring up we're first going to try this. We're going to work on this example here, and there's a lot of historic maps. This one happens to be of the US here, but there's a lot of these historic maps that were made in the last century where, if you look at this closely, one thing is that, first of all, there are no two polygons or US states that have the same color that are touching. So this is called topological coloring, when you kind of use the minimum number of colors you have to use to give every polygon a unique color, while no two adjoining polygons share the same color. So we're going to look at how to achieve that effect. And then you'll also notice that the border of each one of these states has kind of a darker, more saturated version of the fill color. And so here we're going to work on producing this for Danish municipalities in QGIS, using some of the some modern techniques to kind of replicate this old historic map look. And so in this, you're going to first learn about this topological coloring algorithm that QGIS has in the toolbox. And then we'll look at some expression-based symbology using these data-defined overrides that QGIS has. And so to start, I know last week I tried to show this to you with the that climate atlas data quickly, and it wasn't working because I couldn't find, you know, the example I was going to try to show you was using the darker function to give give a darker stroke around each class of polygon layers, and the at symbol color variable was missing, and I had to refresh my memory about that. And so I have another example of that to show you. So this first exercise, I'm going to be working with data that's in the municipalities folder, and there's a geo package in there with municipalities data set. And so I can add this to my project. We're going to start from scratch here. And let me zoom in a little closer. So we have a Danish municipalities layer here, and there's 99 Danish municipalities. If I right click on this and show feature count, I can see that I have 99 features in this layer. That also means that this is what we call a multi-polygon. And if if you hover over a layer in the layers panel, you get both the coordinate system and the location on your computer where that data is stored, so the source of the data. But you notice it also says multi-polygon Z. So that's telling us that this is a multi-polygon layer. And what that means is that if there's a Danish municipality that has multiple islands associated with it, if I click on one of these, all the islands associated with that, or all the features associated with that municipality are part of one feature. So we have multiple islands here, but it's just one feature in the attribute table that corresponds to that. So that's a multi-polygon geometry. And there's tools in the QGIS toolbox from going from single feature to multi-feature and back and forth. But that's what we were working with here. And so to begin with, if I wanted to show you how to use that symbol color, I could click on the simple fill component of this style, and I have the stroke color here. And this item next to the stroke color is, again, the data defined override. And when I hover over it, it gives me some information about what it's looking for. The expected input is a string, so text, giving me the RGB or the color for that particular input. So I can left click on this data defined override to reveal this menu. And I'm going to choose edit to open up the expression engine. And I'm going to give an expression for this. Put it on the right monitor. I'm going to provide an expression for this stroke color, the outline color. And so the important thing here is at the top, when I do this, I'm seeing all of these things in bold. These are all variables in QGIS. And I wasn't seeing that when I tried to do that with that climate atlas data last week, because the data had been rendered using the graduated renderer, and that symbol color is not available when you're using that renderer, but it is available when you're using just a single polygon or a single symbol renderer. So I'm now seeing that symbol color variable, and you can see it gives a value for the symbol color. So what I can do then is expand color and find, for example, the darker function here. And I can use the symbol color as the first argument for darker. And one other nice little trick here is when you're working with this expression engine, and here maybe you've forgotten what the syntax was for darker. What you can do is hit the control key on your keyboard and then click on darker. Whoops, hold on. I think Zoom is overriding my QGIS hotkeys. Normally you can, in QGIS, just do control and click on the function, and it will open up the help for that in the right-hand window. But I think Zoom is overriding that for me. So anyway, here's the darker function. And so it's asking for two things, a color and a factor. The color is the symbol color, and the factor is some value between normally 100 and 200. So if the factor is greater than 100, this function returns a darker color. A factor of 200 returns a color that's half the brightness. So I can go in here and put a comma and put in some value like 150 for the factor and put a clothing parenthesis, and I'm seeing the output preview of a color here. And I can click OK. And now these polygons have an outline that is a darker version of the fill by the factor that I entered. And you can see that I now have this data defined override activated, and there's an expression. And if I hover over it, it now shows the current definition. It shows the darker expression at the bottom of that little yellow pop-up window that I'm using. So here I can also then, now that I have this set, I can go to the categorized renderer and categorize this layer by municipality name and click classify. And now it's automatically using that data defined override for each one of these classes. And let me go into this again, the symbol layer button we're going to work with more today. This is just a way for you to set values for each one of these classes simultaneously. So this is a nice little power user trick to remember. If you want to change an element of all these classes simultaneously, you can click on the symbol button, select the simple fill component, and then you can change those parameters. So for example, I can increase the stroke width for these outlines on all the classes, and you can see that they are indeed darker colors of each of the fills. So I wanted to just give you an example of how that works and how you might implement it. You can't start with something that is already rendered with categorized rendering like this. You have to start from single symbol, set that data defined override, and then you can classify it and have that be honored and work. So that was just one thing I wanted to cover from last week, and it kind of gets us, gives you another example of these data defined overrides. This one can also be used for labels, for example. So if I zoom in closer to the North Shetland area and I want to label this with the municipality name, we have those labeled down. I'll make the labels a little bigger so we can see them. So we have labels in all of our polygons now, and I could use that same kind of data defined override for the color of the labels. I could go in here for the label color, go into the edit menu, and I could use I see symbol color is here again. So I could use lighter this time, just to show you that there's how lighter works. I could use lighter and choose the symbol color variable, and then enter a factor again of, I don't know, let's see, 120 and a closing parenthesis, and I get my output preview. It's working. And now these are lighter versions of each color. And maybe I think they're, too much lighter. So you can go in and edit this and make it, 110. Or I can go in and say, well, maybe that's not really working at all. I'd rather use the darker function. And put in some factor. And now they're a darker version of each polygon color. So you can start to use these to, give very specific and slightly more sophisticated symbology to your layers once you know how to use these. And if I wanted to just not use this anymore, I could left click on this and choose deactivate or clear, and it will remove that data defined override from being used.
Kurt, can you control which edge here, or here's the outline, which outline is on top of the other? Because naturally you have all the borders and it seems like one is prevailing over the other. Maybe it's the name, I don't know which
well,
one
yeah,
is just on top.
It may be the order that they're in the list.
Alphabetically. Yeah.
You can control that. There's this little advanced setting down here at the bottom of the layer styling panel for our classified layer. So I can choose advanced and choose this symbol levels option. And this lets me, if I choose enable symbol levels, tell QGIS the order that I want these rendered in. So 0 would be, you can almost think of these, each line here as being a GIS layer, and the one on the one with value 0 will be drawn first. And since I have 99 layers, the one that had the value 98 would be drawn last to be put on top. So for example, let's see, helical. So if I could make, if I give the helical Comuna here a value of 98, it will be drawn last, and we should now be able to see that boundary above all of its neighboring municipalities. So you can give these different classes numbers, 0 through however many features there are, or how many classes there are in that symbol stack, and QGIS will render them in the order that you number them, with the highest value being the last one and being on top. Does that make sense? Okay. So that's symbol layers, and so you can it's a lot to set up when you have 98 classes here, but when you have data that has a more moderate number, 5 or 10 classes, it's not too hard to set up and can give you nice effects. We'll look at another example of that symbol layer in a later exercise today. So I think I'm just gonna go back to a single symbol for this layer, and I'm gonna clear all of my data defined overrides and give this kind of just a basic default line thickness, so that we can start from scratch on this next, on the first real exercise of the day. So that's a quick introduction to those. So what we're going to do now is start working with topological coloring on this layer. So I'm going to open up the processing toolbox, and you'll see in the processing toolbox there's a cartography section. And most of these tools have to do with either setting up an atlas or importing and exporting styles from a QGIS project or a layer and things like that. But there's one here called topological coloring that we're going to work with. So I'm going to open up the topological coloring algorithm, and it says this algorithm assigns a color index to polygon features in such a way that no adjacent polygons share the same color index, while minimizing the number of colors required. So we're going to run this on municipalities. We're going to take all the default settings. And since I am just doing this as a demo, I'm going to use temporary output. You can certainly choose to save this to a geo package, and you could save this into the geo package that this municipalities layer comes from. So if you wanted to do that, you'd choose save to geo package. You would find the course folder, go into municipalities, and choose the geo package that you want to save the layer into, and give it a name, a layer name, and it'll save it into that geo package. But I'm just going to create a temporary layer. So I'm going to click run. And it has this little icon here now indicating this is a temporary scratch layer. It'll go away when I save my project. And for my purposes today, that's fine. But I can right click on this layer and choose Open Attribute Table. And if I scroll to the right, I'll see a new column called Color ID that this algorithm added to my data set. And I can sort this and see that it goes from 1 to 6. So the algorithm determined that 6 unique values are required to give this layer topological coloring. So with that done, I'm going to switch to my layer styling panel. And now I can use the categorized renderer to symbolize this with a unique color for each category in that field. So I'm going to find the color ID field and click classify. And now I have my municipalities symbolized with 6 colors, and no municipalities share a common boundary. Now, there's some issues here where there may be a fjord between 2 different municipalities, and QGIS doesn't know that. It just sees them as not touching. So to really make things that are in Denmark close, but are technically not touching different colors. You might have to go in and edit those colors. But I'm gonna ignore that for this demo. There aren't any that don't have a value, and QGIS will always include this extra category for null values, but I'm going to select it and remove it because I don't need that. Every municipality has a color code, so that won't be used. And if I don't like the colors that from this random colors color ramp, I can left click on this, and this is another little trick. You can shuffle the random colors. So I can choose shuffle random colors and get a different assortment of random colors until I come up with a set of colors that I like. So I'll just say I like that, and we're off. So we have topological coloring implemented at this point. So now I'm going to right click on this layer, and I'm going to make a copy of it. So I'm going to choose duplicate layer. I'm going to move this duplicate to the top, and I'm going to turn off my original layer and this topological colored one, and I'm just going to have the new copy as my one layer turned on. So what I'm going to do now is a nice little trick. I'm going to use this master symbol button here, because I'm going to make one change to each one of these classes simultaneously. So I'm going to click on this master symbol button, and I'm going to choose the simple fill component. But here, instead of making changes to the simple fill, I'm going to change the symbol layer type. Instead of simple fill, I'm going to choose shape burst fill. So I can give each one of these polygons a shape burst fill. So shape burst fill, again, is just like the inverted polygon shape burst fill you learned how to do in the first class for creating a depiction of the sea, or using it to create a study area mask. This is another use of just the shape burst fill. It's not with inverted polygons this time, it's just a straight shape burst fill. And again, with the shape burst fill, we can go into the shading style, and we're going to use the set distance option. And I'm going to give this a smaller set distance, like a set distance of 3, which again just decreases the distance from the polygon edge that the two colors fade into one another. And then we also have this blur strength setting for the shape burst fill. And I'm going to increase this just a little bit up to about 5. And again, this will control how smoothly those colors blend into one another. So now we have even this is a pretty interesting effect where we have a shape burst fill with all the topologically colored shape burst fills for all the municipalities. So you can see we're already starting to get that old map effect here a little bit. And this distance is in millimeters. So, if I zoomed in to get a closer view of some of these, we'll see that that spread is still in millimeters. So as we zoom in, it becomes a little nicer than when we're zoomed out to the whole country. So now I can click the back arrow and get back to my main symbology for this colored copy layer. And now we're going to make one more copy of this layer. So I'm going to right click on colored copy and duplicate this layer. I'm going to bring this layer to the top. So now I have 2 copies of this layer with the topological shape burst fills. And what I'm going to do for this layer is change it back to a single symbol renderer. So now this version of them, they all have the same single color. And I'm going to choose the shape burst fill component, and I'm going to switch this to a different symbol layer type. And it's just worth remembering that we have all these different settings we can use for polygons. So you can do quite a bit with these. for example, raster image fill, which lets you fill the polygons with a raster image, or random marker fill, or point pattern fill, which let you fill the polygon with little markers like I did with the forest in the first example, the first day. So here we're going to choose random marker fill. Oh, no. Outline marker line. I'm sorry. This one, outline marker line. So outline marker line is similar to marker fill, but here it's going to only symbolize the outline of the polygons. And it's going to do that with a marker line, meaning it's going to put dots along the polygon edge. And the reason why I'm doing this will become apparent in another minute or two. So now I have an outline marker line for my polygons with these dots around each polygon edge. And the reason we're going to do this is because we're going to use some expression-based symbology to create this effect that I first read about on a post from Niall Dawson. You may have heard of. He's one of the very prolific QGIS developers. And he is also very keen to develop new cartographic styles and nice cartography in QGIS. And it was several years ago that he said, today's random QGIS style tip: a marker line with a very small interval, for example, less than 1/10 of a millimeter, with a marker expression based offset, will put random dots close to the polygon edges, gradually fading with distance from the edge. So this kind of creates this historic map look that we're also going to try to incorporate into our map. So that's where I first discovered this technique. So with the marker line, we have a lot of settings here. And the first one here is the width interval. So that is how often along the polygon edge a point appears, a marker appears. So the default is 3 millimeters. And I'm going to reduce this substantially to 0.1, which is going to make these just, bleed into each other. All these little markers are kind of stacked on top of one another when they're this close. Next, we're going to, well, let me see, I think I'll do this in this order. I'll go to the simple marker here. And I'm going to, instead of big red markers, I'm going to reduce the size of this quite a bit. It's going to be just a small gray dot. So I'm going to make this 0.15 for the size of the dots. So they're going to essentially disappear on the map at this point because they're so small. And I'm going to give them a gray fill color. So I'm going to choose an RGB value of 90, 90, 90. And just to remind you, black would be 0, 0, 0. White would be 255, 255, 255. Whenever you have RGB values that are all the same, like 90, 90, 90, it's somewhere on the black to white spectrum. So we can see this is kind of a dark gray. And we're going to set the stroke color to the same dark gray. So I could use recent colors to choose this, or I could pick color and just click on that. Either way, to get that to be the same fill and stroke. And now I have my simple marker. So I'm going to go back to the marker line component of this where I had set that width interval to a very small value. And I'm going to use an expression for offset. That's not good. Where's my open it? I have a document that I need to open that has that. I'm going to copy an expression that I'm going to paste into QGIS here in a minute for a data defined override. So you'll see that there is this is it the simple marker? Yes. For simple marker, where I had set the size for the point very small and the fill and stroke color to gray, if I scroll down, I can see there's this offset section. So this would allow me to offset those points either in the X or Y direction away from the polygon edge by some regular amount. But instead of a regular amount, I'm going to use the data defined override for offset, and I'm going to choose edit and use this expression, which basically, so this offset requires two numbers, an X and a Y. So this number gives the X value as 0, and the Y is basically going to be a random floating point number between 0 and 3. So there's this rand f is the random floating point number function. So this is going to make a random number between a certain threshold. And so I'm going to click OK. And now you can see, let me zoom in a little bit to a denser area of the boundaries. So now we have like this kind of peppered border around the edge of all these polygons, because the simple marker is being offset with a threshold up to 3 millimeters. And you'll see that it's about the same, it's exactly the same distance as the shape burst edge. And that's because if I go back to the shape burst fill settings, I set a set distance of 3 millimeters. And this also, this expression for the offset is also basically using that same threshold of 3 millimeters. So let me show you the slide. This is the expression that I used. It uses the concatenation function, and it's concatenating 0 as text, and it's surrounded by these single apostrophes. So this is a piece of text, and it's concatenating that with another piece of text, which is being derived as 3 times the random floating point value of 0 to 1 to the 3rd power. And so this basically is going to create this random value for the Y offset between 0 and 3. So this 3 here in the expression is what's controlling the distance away from the polygon edge. So if I increase that to 4, those little peppered points would increase away from the edge. If I reduced it to 2, they'd be tighter against the edge. And it gives us that interesting effect. So now we have essentially the effect created. And to finish this up, we just have to do some final touches, which will involve some blending modes and some transparency to these layers. So for let's see, I'm going to give this first solid layer. Let me make sure I get this order right. It took me a while to figure this out the first time, so I want to make sure I do it in the right order. And this will all be in your instructions. So, yes. So first off, with this shape burst fill, we're not seeing the full color beneath it. So I can go to the layer rendering section, and I'm going to increase or set the opacity to like 25%. And then I'm also going to use a blending mode of multiply. And so I can now see the color through the shape burst fill. And for this colored layer beneath, I'm also going to give that some transparency and blending mode. So I'm going to also use a multiply blending mode for that. And I'm going to reduce the transparency a little bit. And to make this a nicer look, I'm going to add a base map to this. I could either use this one from the Danish data Fasooning service, or I could use the OpenStreetMap service. This is an OpenStreetMap base map instead. Any base map you want to use for this is fine. And now we're getting, kind of an approximation of that look. The colored copy, this the random dot boundary, we can also try a blending mode on that. We can give this a blending mode of hard light or soft light, one of these, one of those. And I might even want to give the solid layer a little bit more opacity to be able to see the base map through it a little bit more. And so we now have, something that starts to resemble the first map. You can fine tune some of these settings to make it the effect more apparent if you want. So now with in just a few minutes, with some interesting tricks with QGIS, we've kind of approximated that kind of historic map look, both with topological coloring and an interesting shape burst fill effect, plus the data defined override for this marker line, which creates this kind of peppered outline. And even this by itself can be a really nice touch on any map for a study area boundary or something like that. You can use this effect for other purposes.
Can I ask, I'm trying to follow you while you're talking, so excuse me if I step back, but exactly where you are now on the marker line, I was trying to fill in the random or the expression, but somehow I never got to. Could you just once again tell me where was the place where you actually got to write in the expression for the marker line?
Yeah, it's the simple marker component. So, and then it's this offset.
Ah, right. Okay, thank you.
Yep. Another if you have a if you have a point layer, for example, sometimes you want to rotate points based on something, like if you have, for example, photo points, and you have as one of the attributes the direction the photo is taken. You could use the rotation data defined override and point it to the attribute table that tells QGIS which direction that photo is taken, and you could orient a symbol in the direction the photo is taken. So you can use these data defined overrides for lots of really practical purposes. This one's a little more fanciful and creative, but there's plenty of real world examples where these come in handy as well. So other comments or questions on this? Okay, I'm going to clear this project. I'm not going to save it. And I'm going to move on to geometry generators, which is a really exciting topic. So there's another folder called geometry generators, has another municipalities data set in it. This one, if I right click on it and show feature count, has almost 1,600 features in it. So every single polygon is its own feature. So this is an example of a single part feature. So I hover over it, we'll get a different output. And We're going to use this to show you some examples of using the geometry generator, some simple examples. So I'm going to duplicate this just so we have the original to refer back to as I create new versions of this layer using a geometry generator. So I'll call this this one centroid. And I'm going to work with this centroid copy of municipalities, and I'm going to choose the simple fill component. And again, for symbol layer type, I'm going to change this. And this time I'm going to choose geometry generator, which we haven't used yet. So here, geometry generator gives you some interesting options. It has a choice of geometry. So this is obviously a polygon data set, but I can choose different geometries in the way this is going to be rendered. I can choose polygon, line, or point. So here I'm going to choose a point geometry for this. And it comes up with a default red simple marker. And down here, it has the geometry. So this $geometry is the variable that represents the geometry of each feature in this layer. And so every polygon is represented by this $geometry variable. And I'm going to I'm going to use a function called centroid. So I know the name of this. I'm just going to type it in here, centroid. And centroid just needs one argument. It just needs the geometry. So I can just close my parentheses. So the centroid function just needs one argument, geometry, and boom, I have now rendered the municipality polygons as centroid points. And there's a lot of cases where you may need to do this. And there's certainly a centroid tool that you can use in the toolbox of QGIS. But here we can just render it as centroids if that meets our needs. And if I zoom in down here, you'll notice something strange. If you haven't thought about centroids much, centroids don't necessarily fall within the polygon. So here we have a very oddly shaped polygon, and the centroid actually falls outside the polygon. So that's kind of strange. So what we can do is make another copy of this. And I'm going to choose, I'm going to change the expression for this. And I'm going to use one called pole of inaccessibility. So it's a long name, but I'm going to call this pole of inaccessibility. So on this new copy of the layer, I'll change the color of the marker to something, let's see, I don't know, purple. And so we have that now. And for the geometry generator, instead of centroid, let me show you, how you can find these functions if you don't know them. So if I hit this expression button to the right, generally I'm going to be working with functions in the geometry section here. And you can see QGIS has a huge number of geometric functions. And so the one we just used was centroid, which again just needs one argument. So it's quite easy to use and it's fast. Down below is pole of inaccessibility. So this calculates the approximate pole of inaccessibility for a surface, a polygon, which is the most distant internal point from the boundary. So this will really find something that's maybe more useful for us. So I'm going to use pole of inaccessibility. This one requires the geometry and a tolerance. And for the tolerance, I can just enter a value of 1. And you'll see that the output preview for a geometric expression like this is a point geometry down here. That's kind of interesting. So click OK. And now we have, let me make these points a little bigger. So now we have the pole of inaccessibility for each one of these polygons as bigger purple points. And so we can see the pole of inaccessibility is here. I think this one must be a very small island. Yes. So you can see even for that feature, the 2 points are close, but they're different. And so now we have 2 different point renderings for the municipalities. And you can see the pole of inaccessibility takes a little bit longer for QGIS to calculate than the centroid. So let's go ahead and make another copy of municipalities, and we'll look at another example of it. Geometry generator. I'm going to rename this layer buffer. And again, I will choose the simple fill symbol layer type and change it to geometry generator. This time I'll keep the geometry at polygon. I'll click the expression button to open up this window, and I'm going to search for the buffer. And you can see there's several buffer functions. There's the straight buffer. There's also single-sided, tapered buffer, wedge buffer. So several different options of expressions we can use here. We're going to use just the normal buffer, which requires a distance. And just like with a buffer algorithm, if I include a negative distance here, it will make an internal buffer. So I can choose something, I don't know, like maybe minus 2000, which would be an internal buffer of 2 kilometers. Click OK. And let me change the color of this to something that we can see on the map a little bit better. This too takes a little bit longer to compute. Zoom in here. So now it's rendering those municipalities as internal buffers of 2 kilometers. And the nice part about this is that you might say, okay, maybe that's not what I wanted to show. Maybe I'd rather have that be negative 1 kilometer, 1,000 meters. And you can just change the value and change the way it was rendered. And so it's these can be really handy from that perspective, especially of the case I mentioned before. One of the well, we saw the wedge buffer in here. When I search for buffer, there's a wedge buffer, and this is something I use with field photos, where I can use the wedge buffer, which kind of creates like a pie slice, and I can orient the wedge buffer in the direction that the photo was taken. It's another way to show on a map the field of view, what was in the direction that the photo was taken from the photo point. So there's some really interesting uses of some of these different functions like that. So with that, I want to show you some more examples of these. So this was an interesting map I found on Twitter after the first spring of 2020, when the pandemic started. This reporter for the New York Times published this map that showed where people that lived in New York had moved to work from home when their offices shut down and they had to work from home, and where they went. And so this is this kind of rich area of Long Island outside New York called the Hamptons, and a lot of people went out to kind of summer houses out there to work. And so this is done creating using geometry generator, as he says in the tweet. And he had 2 sets of points, or 2 sets of locations in a point layer, the office location and the home address. And then he used the geometry generator to create these curved arrows between the 2 points. So this is quite a, more complicated expression that was needed to create this, but you can see you can do a really interesting effect because he also was able to, produce a wider line where there was a more people going to that area and a thinner line where there were fewer people. So it really conveys a lot of information quickly. This is a site. Let me get out of PowerPoint and copy this URL for you. This is a GitLab repository by this gentleman, Michael Stutz, and he is a geometry generator wizard. He does a lot of interesting things with them. And I have kind of an animated GIF here of scrolling through this page, starting with this one. And maybe I should actually just go to the web page and show you this instead. So this is the link I just pasted in the chat. And this is his GitLab repo for these. The nice thing about this is he has lots of really practical examples. So this one is dimensions of a polygon. So he has a polygon, maybe a parcel, and he's used geometry generator to render the dimensions and label them of each edge of this parcel, which is really interesting. And also likely a label that calculates the square meters of that. So with each one of these examples he has, you can go here and read about the details of that particular renderer, and you can download the QML QGIS style file for it. So you could bring that into your QGIS style manager and use that style directly on your own data. The only point here is that some of these geometry generators have parameters that need to be changed depending on what coordinate reference system you're using. So if he had set this up, for example, with latitude, longitude, WGS 84 data, and you're going to apply it to data that's in UTM, you probably have some things that you need to tweak to get it to work correctly. But nonetheless, most of the work has been done for you. You just have some of the values to tweak to get it to look the way you want it to with your particular data. But here's another one, dimensions of lines that you could use for roads. Go back to the home page. He has tons of examples, and some are silly, some are useful. This one adds directional arrows. I think you can actually do this with a renderer now, and in QGIS, I don't think you need that anymore. That's a geometry generator. Labels with a leader. This is kind of the effect we just created. Points displayed as buildings based on some attribute. So a lot of, very interesting uses of geometry generators in here that you can experiment with. Another gentleman, Johan Kroger, also has a blog using different geometry generators. So let me post these other resources in the chat too. This one is a Lego map that you can make with a geometry generator. His are a little more silly. And lastly, the Finnish Topi Chukhanov has some interesting examples as well. So you can peruse those. So kind of back to the real world, I've used some of these in my work. So this was a map I created for a client last year where I used one of those geometry generators to show the dimensions of this easement, which was very important to a case that was where there was a lawsuit about this particular little parcel and how it adjoined with the neighbor's fence and things like that. And so it was very useful to be able to explicitly express the dimensions of this using a geometry generator, and then also be able to show it in the legend. these the expression engine of QGIS continues to evolve and grow. So one of the things that was just introduced at 324 was another series of geometric expressions. So there's one called scale that allows you to change the size of features based on an expression. So this is an example of in cartography what is called a cartogram. So a cartogram is when you change the size of features based on a data value to create kind of an informational graphic or map. So this is a cartogram of Danish municipalities based on the population density. So where the population density is highest, the municipality will be basically its true size. But for areas that have a low population density, the size of the municipality is reduced. And so I have a normal municipality layer below it, and then the cartogram on top. And so this is again was done with the geometry generator using this scale function. And you can see the expression in here. And I'll provide these slides to you so you can use this expression. But it's basically the scale function here is using the geometry, and it's reducing that by the population density divided by 500. And so I experimented with a value that would make a nice effect. But that's another use of these. And then there were also these wave functions introduced. And I think I have a live example that I can show you instead here. Yeah. So let me. Okay, so here I just have two lines that are off the coast. And these are just as an example of this wave function. So I made a copy of those before class, and I used this function called wave. And wave is very simple. It just takes the geometry, and it allows you to feed in a value for the wavelength and one for the amplitude of the resulting wave. So for example, I could reduce this wavelength from 15 to 5 and get shorter wavelengths, or I could increase it to 50 and get smoother waves, and you're seeing the original underneath. You can also experiment with the amplitude. So turn off the original, you can see you're kind of creating a smoother wave. And so you can, use this to create all kinds of little wave effects from a line. And so you could do some interesting things with that. And to just show you how nuts people go with QGIS sometimes, not only is there a wave function, but there's a wave randomized function that would let you create a randomized wave. There's square wave, and you guessed it, square wave randomized. Triangular wave randomized. So these may be useful to you. And then to show you one more example that feeds into something we're going to cover in the second hour, this is a temporal animation of a bike ride that me and a colleague did. So this is using the temporal controller, which I'm going to introduce you after our break. And so this allows you to animate data that's based on time. So here it's my bike track that I recorded with my GPS on my bike, and it shows me circling this route around Denmark. But there's different ways when you're using the temporal controller to put time on the map. And so here I have time symbolized as a clock. And this is a single point. It's a point data set that I just put a point there on the map. And I used some of the variables that come with the temporal controller and some complicated expressions to create a series of, basically a series of geometry generator expressions to create this clock from a point. So you can do some really interesting things with it if you're willing to take the time to spend. I don't want to tell you how much time I spent creating this clock. I think it was a couple weekends of solid work to make this work perfectly, but just one more example of how far you can take this with QGIS. Okay, so I think we're just at the top of the hour. Let's take a break and we'll come back in, let's say, like 7 minutes, and we will, or close to 10 after, and we'll continue with looking at the what's next, the temporal controller. Yeah. Sorry, unmute myself. Looks like we're all back. So we're going to look at the temporal controller next. And for this, I have a project that's already mostly built. It's called Buildings in the Buildings folder. And earlier, Charlotte asked about how I could order the polygons when I was showing the municipalities with darker edges so that you could see all the borders. And we looked at symbol layers. And so this is a data set that is all the Inspire building points for this small town in Denmark. And I have the OpenStreetMap base map below it. And with this, if I go to the advanced section, I can see that I have them using a graduated renderer, and there's a year of construction column. And so I have them from red for the oldest buildings up to green for the newest buildings. And if I go to the advanced symbol levels setting, I have these ordered from 0 to 8. So the newest buildings with the highest number will be rendered on top. So this would be basically QGIS renders 0, then 1, then 2, then 3, then 4. So the symbol layers for this allow the newest buildings to be put on top of the older buildings. So the same technique. So what we're going to do here is temporally enable this layer, first of all. So I'm going to, let me open up the attribute table for this layer. And we can look at the available fields. And there's a field over here called year that we're going to use to animate this data. So I'm going to double click on this buildings layer, and that opens up layer properties. And in QGIS for layers, you now have a temporal tab in layer properties. So here I can enable dynamic temporal control for this layer. And then to configure dynamic temporal control, I can choose one of many options. If I just happen to know the time frame, if maybe it's a historic map and I know it's from 1950, I could just set the start and end date for this feature using the calendar widget here. But there's also a choice for a data set that has a single field with date and time. So I can choose that option, and I can see this data set has a date column that I can use. So that's what I'm going to choose. QGIS will only recognize fields that are true date time fields. But fortunately, we have one. And so I can click OK. And now a little clock icon appears here, indicating that this is a temporal layer. So QGIS knows the time that the different features represent. Next to it, there's the filter icon. And this data was filtered so that years of 1000 are taken out of the data set, because that's a no data value for this data set, even though it could be a valid year of construction. They use that as the no data value. So that's the filter is removing those. And now I can open up the temporal controller panel. So this little clock up here will open up this temporal controller panel. And I have 3 different buttons on here. It's disabled by default. So temporal navigation is turned off. I can turn on temporal navigation here, and I can set a range of values, but I can see that QGIS knows that the map has a range from the year 1150 to the end of 2020 here. And if I click on the animated temporal navigation button here, I can start to play time. And I can also adjust the date range. So here I have a starting point of 1150 where the church was built, but there wasn't much going on until about 1850 in this data set. So I'm going to set the beginning of time for this animation to 1850 up through 2020. And so you can see the number of points increases, and it tells you here the current frame. So right now the current frame is 1850 to 1851, because by default QGIS has chosen a step of 1 year. You can choose any step you want. You could have this go faster and play 10 years at a time. And now the current frame will be 1850 to 1860. You can also change the units that you're working with. So anywhere from centuries down to milliseconds. But years works really well for this case because we have years of construction. And so now you can start using the slider to start moving through time on the data set. And as we go through time, we see more and more buildings being built. And of course, there are also different colors based on the classification. You can also simply click play, and QGIS will start playing time. But of course, the one thing we don't see here is the time on the map. We have the readout here of the current frame, but we don't really have a nice label on there for time. So what we can do is remedy that by putting a time label on the map. There's a couple ways we can do this, but one of the straightforward ways is to create a point layer and just label that point with a time variable that the temporal controller includes. Because QGIS knows the current time frame, so we can use a variable to represent that on the map. So I'm going to go to the layer menu, create layer, and I'll just add a temporary scratch layer for this demo. And I'll call this time. I'll make this a point layer in the same coordinate system as the rest of the map. And I don't need any attributes with this. Just need a point. So I'll click OK. So now I have a time layer here, and I'm going to put a point on here where I want this to appear on the map. I'll just stick a point in the upper right-hand corner here and stop editing that layer. So now, this isn't a case where I don't need to see the point on the map. So I can change this from single symbol to no symbols so that I don't see it. I just want to see the label. And then I can switch to the labels tab and tell QGIS I want single labels. But of course, I have no attributes here. I don't have any attributes in my data. So I have to do something else to label this. So I'm going to open up the expression dialog and create an expression for my label. And if I just search for time in here, you'll see that there are some variables for map start time and map end time. So map start time is a really good one here because that's basically the beginning of time for the current map frame. So I can label this with map start time, and that's going to, you can see the preview is from the year, month, day, hour, minute, second. So I don't need all that detail. I really just need the year here. So in QGIS, there are functions for formatting things like time. So I can choose search for format, and I can see that there's a format date function. So I'm going to use the format date function. And one thing I really like about QGIS is that most of these have really good help off to the right. I can see it requires a date time, which is going to be taken care of by this variable. And then it needs a format string. So if I just want the year on the map, I just use Y. The year is a 4-digit number. So I can simply put a comma and then a single apostrophe, Y, another single apostrophe, since this is text, and close the parenthesis. And now my output preview is just the year. So I can click OK, and I'm going to increase the font. Bold so we can see it. So now we have time on our map. There's one other thing we need to do, though. We can see that this time layer, even though it's using map start time as the labeling expression, it's technically not temporally enabled. So I'm going to double click on this layer to open up properties for it. And on the temporal tab, I'm going to enable dynamic temporal control. And this time, instead of a single field, I'm going to choose this last option, redraw layer only. So this just forces QGIS to re-render this layer every map frame, which is a slice of time. So every new slice of time, it will redraw this layer and force that label to be updated. Click OK. And now as I start stepping through time to the next frame, you can see the year increment as I go through this. There are some other, since you're creating this map in the main map canvas and not the print composer, there's some other tricks you can use in here. From the view menu, there are these things called decorations that you can use to add things to the map canvas. So for example, I could add a title label. And I can choose a big font for that again so I can see it. And now I have a nice title on my map, but maybe I want to change the font color to white. So now I have a title on my map. You can even do things. I included a legend graphic in the course materials for this, and I can go to the view decorations menu and choose image. And I can enable image and search in the course materials for that. There's a legend graphic in the buildings folder, and I can tell QGIS where to place this. Maybe bottom right, and then you can choose, if I click apply, you'll see it. It's a little small, so I'll make it larger, and then I can start to position it using these horizontal and vertical values so that maybe it ends up in the forest polygon there. Like that. It appears on a nice place on the map. So now we have a map legend. And then if you wanted to create an animation from this, you can click this Save Diskette and export this out as an animation. So what this is going to do is export a series of still images, one for every map frame. So we have a step of 1 year, and we have, set from 1850 to 2020, so we have 170 years. So it'll export 170 PNGs, and this hash in the name, QGIS will replace that with 0001, 0002 as the name of each image, 1 through X. And so you can also change the time frame here, the step, the map extent on all those exported images, and they'll look just like they do from the map canvas here. Change this back to 1850. So that's how you can quickly set up a nice temporal animation. And, I think showing the time component of data can be a really powerful part of it. I do have, where do I have this? Let me see my other PowerPoint. I have an example of the final animation. So this is what it might look like when it's done, with the title decoration, the label year, the legend, and then just all the frames animated. It's not difficult to stitch these into an animation. There's a couple ways to do it. The open source graphic software GIMP can be used to quickly create an animated GIF. There's also a command line software called FFmpeg, and I give you instructions for using both of those in the step-by-step instructions you'll get at the end of the course this afternoon. So you can use either of those to set up the series of images into an animation, and both allow you to control the length of the animation. And also with FFmpeg, you can choose an MP4 or an animated GIF, or several formats. So questions on the temporal controller? There are a lot of examples of using this. Any data that has a time component can be used this way. For example, radar data, or buildings in this case, any kind of exercise or vehicle movement, things like that.
Well, can you use it for other data other than time? Like if you want to something with changes with depth, like sounding images or something like that, can you?
Well, yeah, I mean, I think with that, if you had a series of like flooding data sets that showed water inundation in under various scenarios, perhaps you could kind of fool QGIS and just tell one was earlier than the next, and use QGIS to animate those, even if it wasn't actually time. You could just use the temporal controller to show one data set, then the next, and the next, and the next, and show that inundation that could happen. So you would just have to create a fake timestamp for each one.
A total timeline.
Yeah. So and you can do that. For example, any data set. If I open up this municipalities project we had, I can go into this data set which has no time associated with it, but I could tell QGIS that it goes from here to here, and now that's where that is. And then so you could just manually set time for those series of data sets, 1 through whatever, so that they played in that order. So any data set can be used in this way because of that. Raster data, vector data, mesh data, point clouds, and any of it can be rendered this way. Every data set has a temporal setting that you can use. And even if it doesn't have attributes, you can set it manually. So the next thing we're going to look at is the 3D environment. And you could use this with any elevation data. Let me set this resampling to bilinear here so it looks a little better. So we have this Mount Rainier color hillshade that we learned how to create last week. And if we want to bring this into a 3D view, it's quite easy. You can close the temporal control panel here. The 3D views are available from the view menu. And you can go to 3D map views, open new 3D map view. And there's been a number of nice enhancements with this, especially at QGIS 324 and 326. There are some very nice enhancements. One of which, this is a panel, this view is a panel. So you can see as I move it around, it tries to snap to the interface. But there's this new button on here to choose to undock or dock this view. So I can undock this, and now it'll just be a free floating window that's not going to try to dock itself to my interface, which is nice because that used to kind of get frustrating when you're on a small laptop, having this window constantly trying to dock as you tried to resize it. So that's a nice new setting. And QGIS will just open this data set in the 3D view, and you have to do some configuration first. So you hit the little toolbar and choose to configure the view. And in this case, you simply have to tell it that it's not flat terrain, that it's a DEM raster layer. And then it throws up this thing like you've done something wrong. I think it kind of scares a lot of people that why am I seeing this big warning message? But you simply have to tell QGIS which layer is the elevation surface. And you can then click apply. And QGIS will basically render this as a 3D scene. And you can then start using the controls here. So you have a compass that allows you to turn the data, and you have some arrows that allow you to tilt the data into 3D. And then you can start to do things like rotate it. And you'll see occasionally I'm getting this kind of defect of striping in here. And if this happens, you can usually eliminate that by increasing this thing called the skirt height, which is basically the edge of the tile will have a little bit of elevation to it. And so if you just put a bigger value, like change this from 10 to 100, it should take care of that issue of being able to see seams in the data set. And you have some zoom in and zoom out controls as well. So with this, there's also this option to create animations. So I can, I think in here, there's actually already a 2 timestamps created. Let me remove those and zoom to the full. So if I start over again and I could set this, I could hit the plus button to make the first keyframe here, and then I could start to tilt the terrain. And I could tell QGIS that I want to add a new keyframe here, and maybe that's 2 seconds into the animation. And then I could start to rotate it and add a new keyframe here at 3 seconds. And you can just, create any kind of series of images you want to create a fly through. You go all the way around the mountain. And then maybe zoom in. And continue to explore you can also use your mouse buttons to do things like move the terrain as well. They've done a lot of work to make this a little more intuitive. So I have added 8 keyframes, so then I could click play, and QGIS will start playing my animation. with all the keyframes that I set in there. And in a similar way as with the temporal controller, you have this export animation frames. This would again just export a series of still images, and you would stitch it together into an animation the same way you would do as output from the temporal controller. Some other nice features with this is that there is also, there's a measure tool. If you just like this itself, you can export this out as an image. And there's this new function here to export this scene. So there are other specialty 3D softwares like the open source tool called Blender. So you can export out a 3D scene from QGIS and import it into a software like Blender and continue to work on it. So that's what this export 3D scene would do for you. And another nice new feature in QGIS is that it used to be that when you opened up a 3D scene and closed QGIS, it would just disappear. But now there is, from the view menu, there's a manage 3D views option. It's kind of like the print composer for 3D views, or the print manager, I'm sorry, for 3D views. So I can like rename this 3D view and click OK. And I could duplicate it, and I could have multiple 3D views in my composition, in my project, and they get saved. So if I close this, I can now go back to my view menu to 3D map views, and I can see I have two different 3D views in here, and I can open up the manage 3D map views, and I can choose which one I want to open and click show, and it will open up that other 3D map view.
So I don't have the 3D map view thing under my view menu.
You don't? What version of
I
QGIS?
only have, I just have the new map view or new 3D map view, but I don't have the map view manager. Or
Okay, that is because
I think maybe it's because I'm on 322. So you said it was new. Is like brand new or?
well, it's it was introduced, I believe, at 324.
Huh.
So
Okay.
you're at 322. So
Yeah, I think
the next LTR is going to be 328.
Yeah.
And that's going to be in about 3 weeks.
Yeah.
So within 3 weeks, when there's a new LTR, whenever you manage to get that installed, you'll then have this 3D map.
Yeah.
Yeah.
Only the state knows.
Yeah. That's right.
But that's fine. It's okay. But I just figured it was because yeah, I'm behind.
Another thing that you'll be missing, but we'll get very soon then, is this new elevation profile tool. So QGIS now has, as of 326, an elevation tab for elevation layers. And so you can create some settings for your elevation surface and how to style the chart from layer properties. You can then go to the view menu and go to elevation profile. This will open up a panel below your map canvas, and you can either capture a curve that you trace on the map, or you can capture a curve from a feature. So here I have a hiking trail up Mount Rainier, and if I click on that, I get an elevation profile, the way I'd set it up style-wise, of that route going up Mount Rainier. So that's a brand new feature that just came out late last fall at version 326. So that is nice. And if you ever work with point cloud data, this tool for elevation profiles works with point clouds too, which is quite interesting. So here I have a point cloud that's styled with RGB values from a satellite. And if I draw a line on my map canvas where I want an elevation profile, I will get an elevation profile of this point cloud. So this is individual points, but I have a tolerance setting in this elevation profile that I can increase, and it increases the swath the width of what's being sampled from this point cloud. And if you increase it enough, you get a really nice kind of rendering of what is in that swath and what the elevations are. And so you can make measurements in here using the elevation profile tool. And with point cloud data, you can actually snap to individual points that you're seeing in the profile and measure the height of a tree or the length of a roof or what have you. So this is a nice new feature that just came out at QGIS 326 related to that.
So can you control where's your point of view, the height of where you look at your point cloud?
Well, yeah, there I drew a line on the map canvas, so you can draw any line.
Yeah.
On the map canvas, with curves on it and things. So yeah, any line, or you can use a linear feature like that hiking trail and just get the profile of that linear feature. Either way. Is that?
No, I'm meaning the it's like a kind of a line of sight here, or what? No, it's not a line of sight, but what can I actually see from a specific point?
That's a different procedure.
Yeah.
So there is there's a plugin for doing that, Charlotta, and maybe we can look at that at next week's question and answer, because there is a line of sight plugin that adds those kind of tools to the processing toolbox.
Cool.
Yeah.
One thing with the previous picture of the point cloud, will it stack the points, or how does it when you increase the width of the corridor, how does it display the data?
Well, I think it's showing I think left to right, front to back, like the direction you digitize the line. That's a good question. I might have to try it, digitize the line the other way to see if it changes the view at all, but I assume it's going from left to right in the direction that you drew the line, but I don't know for sure. That's a good question. I can try to find that out. It's such a new feature. I haven't used it enough to know that kind of detail.
But it's really cool to get a quick overview before you actually work deep down with your point clouds.
Yeah,
I think. Yeah.
Absolutely. So the last thing we're going to look at is mesh data. So we have about 20 minutes. So let me quickly talk about this, because I imagine this is new to a lot of people. So mesh data is kind of a hybrid model. It kind of has, especially in the way we can style it, it has features of vector and raster data, but it's basically a mesh. It's so it can be a square rectangular mesh like a raster, or it can be triangular, or it can be irregular, and it's produced frequently for weather related data, hydrological data, outputs of flood modeling and things like that. And the interesting thing is that a mesh data set can contain multiple data elements within it. So what I'm going to show you now contains wind, temperature, and precipitation plus time. And so we can look at any of those aspects in the mesh data set. So what we're going to work with is this data set from the December hurricane in Denmark from 1999. And I think it was supposedly the highest wind speed ever measured in Denmark. And let's see. The data source for this is this Copernicus Climate Store. They have this fantastic pool of data that goes all the way back to 1979. So you can go back online with this tool and select which components you want. So I selected precipitation, wind, and temperature. You can then choose the time frame and the area that you want to download that for. So you can drag a box or put the coordinates in for Denmark, for example, or Sweden, and then the time frame if you want to show a specific storm like this, and then download that data. And let's see, we'll get to that. So here we're going to be in the mesh folder, and we have this file that is a .grib file. So grib is one of the file formats for mesh data that's supported by QGIS. And mesh data sets get this icon, this kind of irregular mesh looking icon. So if I just drag and drop this from the browser panel into QGIS, I'll see this mesh data set. And I have a geo package in here with both a pre-styled layer for Denmark and one for surrounding countries. The last thing I want to do is put this into the CRS of the these vector layers, so things look a little more like we expect them to. Okay, so we have just hollow outlines for these two vector layers, and the one we're interested in is this mesh data. And so what we just have been through, you can see right away that there's a clock next to this. The QGIS automatically recognizes that this is a temporal layer. And if you click on this icon, it's a shortcut to open up layer properties to that temporal tab. And you can see that QGIS knows that this data set is from December of 1999, and specifically from the 2nd to the 5th here. So it's 4 days of data. So we don't have to do anything with that. QGIS recognizes it automatically. But we've been working with the layer styling panel, and you can see when you're working with a mesh data set, you get a very different set of controls on the layer styling panel. So first off, if we go to this main tools setting, you can see that we have 3 different data sets in here: wind, temperature, and precipitation. And we often have to expand this a little bit until we can see these controls over off to the right. This little colored icon next to wind indicates that what we're seeing now on the screen for this is wind data. And so we can go to the contours tab to style this and choose a different color ramp. So for example, I could choose red, yellow, blue. And I know I want to invert this to have the higher winds be red and the lower winds be blue. And you can stretch the colors by changing the max here to give a little more emphasis on the higher wind in this case. And then I can go back to my data sets tab, and I can see there's a little grayed out arrow here. We can also render vector icons with for the wind, because that little grayed out icon is there, but I have to click on it to make it black, and then I'll see these vector arrows show up on the map. And I can go to the vectors tab to configure those. So first off, I can change the color. So I can make them maybe a dark blue instead of black to make them blend into the map a little bit more. I can do things like choose display on user grid, and I can set the density that I want the grid to be. So I can change this maybe 20 by 20 pixels instead of 10 by 10 to make them a little sparser. And then under arrow length, I can choose to scale these arrows to the magnitude of the wind, so that they actually represent get a longer arrow where there's higher wind, for example. And then I need to reduce the scale by factor to something a little more reasonable, like 2. And now I can open up the temporal controller panel and activate temporal control, and I can start to slide through the time for this data set until I start seeing the storm. There it is. So we get the vortex of the the wind coming into Denmark here about halfway through the available time. We can see the storm hit Denmark, move into Sweden. So this is one way to show the vectors. I go back a little bit in time here, where we get that nice vortex. This is the arrow symbol. There's also streamlines, which for this data set get a little overwhelming. You can certainly change the settings for the user grid to make them more sparse, perhaps. But the one I really like are the traces. So this kind of shows a really nice kind of organic looking wind map, where we really get a sense that these actually kind of, if you look at one, they kind of start with a bigger head and tail off and get thin near the end. So they really do a nice job of showing the wind. So that's, really what you can do with this kind of data. I could also let me duplicate this layer and make another copy of it. I could also have a version of this data set that does not show the contours and only shows the vectors, for example, and I could make them white. Why am I still seeing the... I should not be seeing the contours anymore, but I am. Maybe I need to... I've actually never tried to just duplicate a grid layer before. Maybe it doesn't really work well. So here, let me just change trying to turn that off. It's not turning it off. Huh. I wonder if it's a bug. Or maybe I just need to... There, let's reduce the opacity. So what I was going to show you is that I could add a base map like Google Satellite. And I could change these vectors to the traces, but make them white. And, show the data like just the traces on a base map of aerial photography, which can also be an interesting view of the storm. So you have some options for how to show this data. And with these traces, you can choose a maximum tail length. You can set that and also increase the particle count, which is the number of traces that are shown on the map. And so since it's already temporally enabled, creating a temporal animation is the same process. Export the animation and stitch it into an animated video of some kind. And so here is an example of that, where I just added the title decoration and a date and timestamp, and exported this as an animation with the traces. And this is kind of what it could look like, again, on just satellite background with just the traces being shown. And then another famous storm in Denmark was Bodil in 2013. And this one, I can't remember if I have the data in your folder or not, but if anyone wants it, you can just ask me for it because I have the file and I could easily get it to you. And for this, Denmark's Meteorological Institute also has open lightning data. And so at one point, I was interested in exploring that. And so the lightning data comes in as a CSV with coordinates and a timestamp. So since it has a timestamp, it means you could incorporate that into this temporal animation. So for Bodil, I added the lightning, and I used just a little bit more complicated temporal styling of this, which has the lightning come in as a big fat dark purple point and fade to a light point. I had to make the strikes last like 4 hours instead of an instant so that they worked on the animation. But it's another interesting thing to add to a weather animation like this. And I think I can find that. Did I? I was gonna see if I can open up that project so I can show you the temporal animation settings for that, because it's kind of interesting to wrap up here. There it is. Okay, so here's the lightning. And so it probably come as no surprise, I use data-defined overrides to control the size and the color of those lightning points through time. So here, another setting you have with these data-defined overrides is using the assistant. So what I did was use this assistant down here, which allows you to enter an expression for the time here. So I'm using, again, the same thing I use to label time. I'm using the map start time minus the timestamp in the data to kind of get the duration of time in hours that this particular every particular lightning strike represents. And I scaled the size of the values from 0 to 4. And you can use this thing called this transform curve to control how quickly the lightning point starts out. So, and this is the size, this is the symbol size option. So they start small but quickly get to full size at a point size of 4, and then decay gradually to 0 until they're small. So this transform curve can be used with temporal data to control the decay of the size of something. You could have it start small and get big, or start big and go small, using this transform curve. And I use the exact same transform curve for the fill color. Oh no, I didn't actually use a different one. It's a little different. It starts at a dark purple and goes to a light purple against this color ramp. So if anyone's interested in this, I'm happy. I actually have this saved as a QML style file, and I'd be happy to send it to you if you want to look at this. I could send you the whole project if you want, so you could explore it. So if you're really interested in that, just let me know, and I can email the project and the style file with you so you could explore this. I think that's everything I wanted to cover today. Yes. So feel free to ask any questions, but I will be, again, the same thing, recording this session and sending it out to you as a YouTube video so you can rewatch it. And I'll be giving you another assignment, which will be very similar to this, where you can follow instructions for each one of these. I think I'm only asking you to do one animation, either from a 3D view or a temporal controller animation. You don't have to do every single one, because I know everyone's busy, but that way you get experience doing the one that interests you the most, and you'll get to try all these techniques in the assignment. So are there any questions or anything you would are wondering about?
I have a question. It's not. Oh, go ahead, Kel, because mine is not referring to the exercises. So you go ahead.
Well, mine's not actually either. It's the traces on the map we're watching right now. How do you think of the traces? Is it how long for time, or I mean,
Well,
it's like the mesh of vectors, isn't it? But just traces instead.
yeah, so the mesh data has this wind value for every facet that makes up the mesh. For every piece of the mesh, it has a wind value for that timestamp. And so you can set a maximum tail length here. So for the strongest wind, it's going to have that maximum tail length, and as I understand it, it shortens it and thins it out if it's a smaller value. So you can see some of these are a little shorter and some are a little longer. So that's controlled by a proportion of the data value and this max tail length. And this
So
is
the
in
longer
millimeters. So the longer tail lengths and the denser tails and traces would be where the wind is the strongest, as I understand it. And where the wind isn't as strong, they disappear entirely at different time points.
Okay, so the trace word can actually be seen as a trace element, a small element of wind moving longer when the wind speeds are higher and staying more or less in the same place and fading out when the wind speed is low.
Yes, and it also shows the direction of the wind as well. Yeah. Charlotte?
Sorry. So mine was regarding your web, in the menu bar, your web menu, yeah, in the menu toolbar, your web.
Yes.
And I just noticed you had a lot of nice VFS and VMSs there to choose from.
Mm-hmm. This is from a plugin called Quick Map Services.
Good.
You know, we in Denmark and lots of countries have very nice open data, but Quick Map Services is a global service, and so this will work anywhere, and it comes with probably almost 100 different base maps in it.
Yeah.
And I'll show you one trick with this as we're closing out here. It will appear once you install Quick Map Services from this web menu, and you're going to have to do this the first time. You go down to settings here, and from the settings menu, where is it? You want to click on this more services tab and click this get contributed pack button. Until you do that, it only has what services that are completely open. After you've set that setting, then it will add things like Google services, Esri services, Bing services.
Whoa, that's
as
so
well.
cool.
Yeah.
Oh.
So you can bring in Esri based maps and OpenStreetMap based maps and all kinds of things. So yeah, it's a great plugin.
Cool.
All right. Anything else as we close? Okay, well,
I'm not going to look at all those maps until I've finished my assignments.
Yeah.
Yeah. Well, thanks everyone. I will
Thank
see
you.
you next week, next Thursday, for our final question and answer session. I know we already have one thing I'm going to try to cover then. And if you run into any troubles over the next week, just email me and look for your assignment later this evening.
Cool.
All right.
Thank you.
Thank you.
You're welcome.
Thank you.
Bye for
Bye.
now.
Bye.
Bye.